So we're well on our way to using the Nebular Hypothesis to see how our solar system formed. And I think what we have sort of agreed upon is that we're going to spin and we're going to be flat in terms of our solar system. Okay. The next issue that is one of my favorites here, and let me try to convince you of where the sun came from. Okay. So what we have here is we left in the last videos, we sort of have our big ball of dust is just now flat, and of course it's still spinning. Okay, so we're just sort of done with that. Just remember that it's spinning, it's getting flatter, equilibrium's been reached, and there's not a lot more that's going to happen. So what I'd like to focus on is for where the sun might have come from then, is these inner regions here where, of course, as we said a few times, gravity is always pulling things inwards like that. So what we'll do then is suppose we sort of focused our attention very carefully on this inner region here for a minute. We really zoomed way in there. This is about as far as I can go with the iPad then, and we started looking at what might be going on in there with this gravity. So, okay, we're still on this issue of having dust. So there's some dust, and there's some dust, and there's some dust. Remember, we zoomed in now. And what we think might have happened in these regions where gravity is always pulling things in is there might have been started to get a lot of collisions going on between the dust. Okay, a lot of collisions. Let me go to a really thin pen here for a moment. So this dust particle here might have been going this way, and this one might have been going that way. And remember, they're sort of being attracted to each other by gravity. And so what could happen sort of in here is that maybe they'll collide. Okay, so in other words, if we have a bit of dust right here and a bit of dust right here, and this one's going this way and this one's going this way, so at some point they'll get to be sort of like this and this, and right here at this sort of interface between them here, they'll rub against each other. Okay, and so I think we did this in a previous video, but again, if you take your hands and put them together and rub, they get very warm. And so the same thing will happen to these rocks in here. So right at this surface where they sort of rubbed into each other, they'll start to get warm in there. Okay. And just remember then that I'm only talking about maybe two little dust particles or rocks or whatever you might happen to find in this inner region of dust here, sort of starting to rub together here. And what they're doing, they're starting to generate a lot of heat in there. So what we'll do then is I'll just draw a bunch of dust particles in here for the moment then. And we'll just assume then that according to that little picture, there's a lot of collisions going on because gravity keeps pulling things together. And as they collide, I'll just start drawing some orange in here. And the orange indicates where some heat was sort of built up because of these collisions. But the collisions don't stop just because the rocks are getting sort of a little warm now and again, almost like our hands rubbing together. That's definitely not going to stop the collision process. And it just keeps happening more and more and more. And so what you would do in the center region then is this heat's going to start to build up. And so while I have little wisps of heat drawn now and again on edges of rocks here, collectively as a whole here, the heat's just going to start building up. So maybe I can even do something like this, get some nice hot colored sort of ink in here and just draw some orange stuff developing here. It just gets hotter and hotter and hotter in there like that because there's all these collisions. But gravity keeps pulling things together. That's never going to go away. And if some things collide and maybe stick together, they'll get larger, and so maybe we'll get even larger and larger collisions. Maybe some speed will build up and all that sort of thing. So the point is that this center region here, and the reason why I'm highlighting the center region again is not just randomly, is because remember the centrifugal force is minimal here. And gravity, doesn't quit for these two reasons. Primarily this one here, the centrifugal force is minimal. The only thing really acting on the dust in this region here is gravity pulling it all together. So lots of collisions, and the centrifugal force is minimal. So nothing to pull things apart or out or stretch them or anything like that. But the bottom line is what starts to happen in the center there is it starts to get really hot because of all this heat, of all the collisions going on. So you'd imagine the inside there getting very, very hot. Okay. All the collisions under gravity there. That's fine. Okay, so what? So what that some of the rocks are starting to get a little bit hot in there? Well, remember that what's the dust is made out of now. Don't forget that the dust is made out of basically mostly a bunch of hydrogen. Okay, that's what's sort of in there. Okay, now what is hydrogen? Well, it can be a couple of things, and maybe as it starts to get warm, it can be a proton like this, and maybe one of the other collisions in there will be with another proton in there, okay? And these aren't the details, but what can happen then is you'll get helium plus more heat. Okay, and we've seen this before, and you can go review the videos on this, but this complete thing here was discussed in the proton-proton chain. Okay, that's where that was discussed. And what this process here, this is the process of fusion. And so what I'm telling you here is that as things got hotter and hotter, it started to get possible for two helium nuclei here to actually come together and fuse and form helium plus all that heat that comes out there. That started to be possible. In other words, it got so hot, because remember, one of the other laws of physics that is not really important here is that these like charges like to repel each other, right? So we have a positive and a positive. They don't like to come together. But it was so hot, and when things get hot, as I think I showed you in the proton-proton chain video here, they start moving so fast, so hot and so fast that suddenly the protons, which like to get away from each other, suddenly can come together. And let me just draw this clearer here, because that's definitely what happens. The process of fusion begins. And of course, what fusion is that's what runs stars. And so you'd go back then to the central region of the solar system right here, where you're just saying it's getting hot, but the collisions keep going, the heat keeps building up, and it gets so hot that some of the hydrogen in the dust can begin to fuse, and the star can turn on. And so then what happens then is the heat might very well just start becoming a glowing star like that. So there might be the formation or the ignition of a star, so star ignition. But what I just love about this theory here is that the star ignition can certainly happen for the reasons that I outlined right here. But what I just love about this is that the initial heat that had to get this going here, to get these two protons to fuse together, just came from friction between all of those rocks rubbing and colliding with one another. And so now if you just step back with all the stuff we've been discussing and just sort of look what's inside that red box, what do you have now? You got some flat dust that's spinning. You got yourself a star in the center that was started by the immense heat of all these rocks colliding together, frictional heating. One of the physics things we discuss is important here. And it got so hot that fusion could begin. The star ignition happened and fusion could begin going. And of course, once fusion happens, all of this heat that comes out of the fusion reaction just feeds additional heat in there to make things even hotter or more fusion to occur. And the sun starts to glow. And so look at all the things that have happened though with all just these diagrams we've been drawing. Flat spinning dust, and now we even have a star in the center.